Welcome to SolidCAM Professor in a video series to help you get started with iMachining. In this session, we will discuss using iRest and iFinish. When using iMachining, it is possible to perform an iFinish operation directly after an iRough. The previous videos used a part where this could be done. In this case, we will use a part that has areas where the roughing tool will not physically fit. As a result, we will use an iRest strategy to clear out the remaining material before using iFinish. First, let's open our example SolidCAM part, SC Electrical Housing Part 1.prz. Note that this part file does not come with the installation of SolidCAM. The example file will be included with this video tutorial. The part file can either be opened directly from our Getting Started interactive guide or by first downloading it here from our website. I saved my downloaded part file to the SolidCAM training folder that I've created on my C drive. I recommend you do the same. Note that a milling cam part has already been created for this, where we have defined the CNC controller, coordinate system, stock, and target. We have also selected the machine and material databases for the iMachining data during the cam part definition process. In the cam tree, double-click on Tool to open the tool table. You'll see that I've already defined the tools we'll be using in this exercise as well. We have an 8mm and 6mm diameter end mills. Let's click OK to exit the tool table. Now, let's create a new iMachining operation. Right-click on the Operations folder in the SolidCAM Manager, Add Milling Operation, and select 2D iMachining. This will be our roughing operation, and we'll use the default iRough strategy for our technology. First, let's define our geometry. Click the New button. Here we have a closed pocket with 3 islands. Pick on the lower contour of the pocket in the SolidWorks graphics area, as shown here. For this example, we cannot use Auto Constant Z alone to close the chain because of this smaller pocket. Using the Geometry Edit dialog on the left, let's select the Auto To function along with Auto Constant Z. Pick the lower contour of the pocket in the SolidWorks graphics area, as shown here. All connecting entities on the same Z level will be automatically selected up to that point. Next, let's select Point to Point from the Geometry Edit dialog on the left. Pick the 2 points off the model in the SolidWorks graphics area to close the chain, as shown here. Then, click Yes to accept the selection. Our toolpath will work inside this geometry. Next, we will define the geometry for the islands by using the Geometry Edit dialog and picking our chain selections right off the model in the SolidWorks graphics area, as shown here. We can accept each geometry selection by clicking Yes when prompted by the OK to Accept dialogs. Our toolpath will now work around these islands. Once satisfied with all of our selections, click OK to close the Geometry Edit dialog. Moving down the tree, let's select our tool from the tool branch. Click Select to display the tool table, then select the already created 8mm end mill from the list. Click Select to exit the tool table. In the Levels branch, let's set the milling levels for this operation. Click on Upper Level and select the top of our stock model from the SolidWorks graphics area. Then click OK to accept the selection. Next, we will pick the pocket depth by selecting the Pocket Depth button. Pick on the lower face of our pocket to set the machining depth. Then, click OK to accept the selection. We'll use the default cutting conditions generated by the Technology Wizard with a machining level aggressiveness of 3. In the Technology branch, let's make the wall island offset 0.12 millimeters. Now, let's click Save and Calculate to add this iRough operation to the cam tree and calculate the iMachining toolpath. Then, click Simulate to display our simulation control panel. Using our default HostCAD mode, let's take a look at the wireframe toolpath at work. The pocket is split into 2 areas, both containing a helical entry followed by the pocket roughing toolpath. Due to the 8mm tool size, we can see it was unable to fit through these small spaces. Let's now perform a rest material operation using iRest. We will exit the simulation and then simply click Save and Copy to perform a copy of the current operation. After the dialog automatically opens, Let's change the operation type to iRest using the drop-down menu under Technology. We will use the copied geometry selections from the previous iRough operation and can view them by clicking on the Show button in the Geometry branch. Then, exit the Show Geometry dialog. Next, we'll want to select the smaller 6mm end mill from the tool table to do our rest machining. Click on the Tool branch and then the Select button to display the tool table. Select Tool number 2 from the list and then click Select to exit the tool table. Moving down the tree, we'll use the copied milling levels from the previous iRough operation. We will use the default cutting conditions generated by the Technology Wizard with a machining level aggressiveness of 3. In the Technology branch, there is a tab called iRest Data. There are 3 important values for calculating rest material. They are previous tool diameter, previous wall offset, and previous fillet radius. By default, the parent operation is chosen and the fields are filled with the associated values. These values may also be entered manually by selecting User Defined from the drop-down menu. You'll notice the fields are now open to be edited. Let's leave the default iRough Contour. It is important to know that the wall offset for rest material must be greater than 0, but less than the previous wall offset. We can compare those values under the iRest Data and Technology tabs. For this exercise, let's select the Corners Only checkbox in the Rest Materials section. When the option to clear corners only is selected, the wall island offset is inherited from the previous iRough operation and the input field text box becomes locked. Now, let's click Save and Calculate to add this iRest operation to the CAM tree and calculate the iMachining toolpath. Let's click Simulate. Let's take a look at the iRest toolpath using HostCAD. Slow the simulation speed down a little, and then press the play button. Using Corners Only, we can see the toolpath working in the bottleneck areas as well as clearing only the corners. Let's now use iFinish to perform a final finish pass along the walls and islands of this pocket. Exit the simulation and then simply click Save and Copy to perform a copy of the current operation. Again, we will change the operation type under Technology. Let's choose iFinish from the dropdown this time. Most of our selections will remain the same: the geometry, our 6mm tool, and milling levels. We'll also use the default cutting conditions generated by the Technology Wizard with a machining level aggressiveness of 3. Let's click on the Technology branch and move to the iRest Data tab. We can see that our previous iRest operation is selected as the parent operation by default. The fields are automatically filled with the 3 important values needed for calculating rest material. Let's switch back to the Technology tab. Note that our wall island offset is now set to 0. Under the Finish section, we are now presented with our options for this iFinish operation. We will only need to finish the walls and not the floor. In this example, we can select either total depth or each step down under the wall finish section, since the total depth and step down value are the same. Let's also select the Spring Pass checkbox. Spring Pass will perform a secondary finish pass along the walls to ensure our pocket is finished more accurately and dimensionally correct. Now, let's click Save and Calculate to add this iFinish operation to the CAM tree and calculate the iMachining toolpath. Then, click Simulate to view our toolpath at work. First, we'll take a look at the iFinish toolpath using HostCAD. Slow the simulation speed down and then press the play button. Click on the Solid Verify tab, slow the simulation speed down, and then press the play button once more. Now we'll view the cutting tool in 3D taking a pass along the walls and islands followed by the final spring pass. Let's exit the simulation. It is important to know that rest machining pulls data from a previous parent operation as shown before in the iRest Data tab of the Technology branch. If one of these 3 important values changes, the data will update, but the latter operations will need to be recalculated. For example, let's exit the iMachining operation dialog and edit our iRough operation. Double-click iRough Contour in the SolidCAM Manager to open the operation dialog. Switch to the Technology branch and change the wall island offset to 0.24 millimeters. After clicking Save and Calculate, we can see that our iRest operation is no longer synchronized, as shown by the asterisk in the SolidCAM Manager. We'll need to exit our current iRough operation, then simply right-click on iRest Contour in the SolidCAM Manager and select Calculate to sync it. While in the SolidCAM Manager, let's generate G-code. Right-click Operations, G-code All, Generate. The generated G-code for a 3-axis Haas SS opens a notepad for us to view. And this concludes our 4th session in the SolidCAM Professor video series to help you get started with iMachining, where we discussed using iRest and iFinish. Thanks for watching. Please join us for our next few sessions, where we'll define different types of geometries.